Quizam Part D of this stuff. We'll do this on Friday. I was trying to do French. Part D. D-U-X. Whatever.
Just say ducks.
So what we're going to do here is, as I was going through my notes yesterday, trying to make sure I was setting everything up correct for this week, I had forgotten that we are going to do systems of conics. We have done in the, or you guys have done in the past where you have looked at the intersection of two lines, and you would find this point. You've done systems of equations before. In order to do that, you guys would use linear combinations, substitutions, or eliminations. You've done it. You guys are good at it. All right? What we're going to do tomorrow is we're going to look at the following. We're going to take an ellipse and a circle and see where they can intersect.
Everywhere. Gross. Everywhere.
Gross. So you can have, in all honesty, you could have a circle and an ellipse in 4 places.
Saturn.
It does. You could have it intersect in 2 places.
1 place.
It could be intersected in 1 place.
360 places.
You can also, if we look into it further, we're going to talk about the hyperbolas. We're going to have parabolas also, but if we have hyperbolas,
They can touch a circle in 4 places.
we could have those intersecting into the ellipse also. We could have hyperbolas, ellipses, and parabolas.
You can make a basketball. Is this happening on Friday?
This is actually very simple, guys.
That's what they all said.
Hold on. We're going to do the same. Okay, we're not going to do the 3-1 like this. That's just awful. We're going to probably talk more about just the 2 conics, maybe throwing a linear in there or not. What's going to happen here, it's nothing more than just solving a system of equations. It's very simple. You've done it.
You're going to give us a formula, right?
There aren't formulas. Oh, for the Quizam? Yes, sir. Absolutely. You guys can select your formula for that, okay? But I do want to go with you guys as far as how we set up the shift in hyperbola. Yes, sir.
So the Quizam is everything from the last Quizam to the...
Yeah, it's going to be shift. It's going to be hyperbolas and the system stuff. Okay.
Oh, okay.
Yep.
Gotcha.
Can we get a real calculator?
I haven't decided yet.
Yes.
Okay.
Decided on what.
So let's talk about the shift in hyperbola. If you guys remember when from about a week ago, last time we talked about this, I don't have much stuff to go over with you guys today. It should be relatively quick if you stop talking. Do the a squared and the b squared matter with the hyperbolas?
No.
What matters with the a squared and the b squared is going to be what comes first, the x or the y. Thank you. Okay? That's what matters here. So if the x squared term comes first with the hyperbolas, that means we're going left and right.
What?
Yeah, if the y squared comes first,
I screwed it up.
that just means it's moving up and down. Now, the other thing that we've been talking about over and over and over and over again with these things is that what are the values of A, B, and C? What do those mean? A is always going to be your distance from the center to vertex. B is always our center to the co-vertex. C will always be your center to your foci. And then when you're dealing with your hyperbolas, in order to solve for A, B's, and C's, it was A squared plus B squared is C squared. Okay? The rest, all the other stuff that we've worked on, those distance values, you get A, center to vertex, B, center to co-vertex, C, center to focus. That was always the same whether it was an ellipse or the hyperbola. The only difference between the hyperbola and the ellipse is that you're A squared plus B squared. One of the easy ways to remember that is the formula for the hyperbola has a subtraction symbol between the two, which means when you find C, it's got a plus. Whereas the ellipse had the plus between the two, and it was minus between them. Okay? It's a very easy way to remember that. Other than that, I mean, the only other thing we have to mark out is our slopes of our asymptotes. I know that we talked about there is a shortcut way to remember how to do, whether it's B over A or A over B. I always forget which one is which. So I'm going to show you guys and remind you how you can get those slopes with just when you draw up that rectangular box. Very easy. Always going to work. So, what's that? It's just rise over, yeah, just rise over. That's why I just do it with that box part. It's much easier. You're never going to forget it.
I thought I messed up.
No. Because I know, remember how in the formulas it says it's either B over A or A over B, depending upon which way it's going?
Yeah.
Who cares? Just do rise over run.
Okay, thank goodness.
Yes, yeah. So this being the last of the conics that we're writing equations for, I'm going to do it differently. Instead of graphing first, we're going to... No, we're going to write equations first.
Right, yeah, do it, guys.
Oh, yeah. I should have known.
So let's do this backwards. Let's start with the hyperbola with given foci. Our foci are at 5 and 2, 5 and negative 6. And we have vertices at 5 and 0 and 5 and negative 4. And I'm going to write the equation of all this. Let's do it.
We should graph first.
Correct. Just like we've done in the past when we had the equations to start out with. What do we start with by doing? Plot it. When we graph this, we're going to get an idea of what direction this is going. That way we know whether it's going to be an x squared or a y squared hyperbola.
It's going to be an x squared, y squared. It's going to be a...
Hey, guys, let me get that.
There's 5. There's 2. 5 and negative 6. Those are my foci. Vertices are there and here. What directions are these opening? What about that? Yeah, exactly. So is this an x squared or a y squared? Y squared. So I'm going to start by writing it out. Y minus k, quantity squared, x minus h, over a squared, over b squared, equals 1. I'm just going to write that down to start with so I know what to fill in as I go along. Okay? No, you don't have to. What we're doing here is just getting the visual to know which way it's going. That's it. You don't really need to plot this one out at all. Now, just like we've done in the past, we're going to figure out where our center is. Remember, your center is always going to occur at the midpoints of the vertex, of the focus, co-vertex. It's always going to be the midpoint of any of those values. This one works out pretty clean, because what's 0 plus negative 4? What's half of it? So it means our center is at 5 and negative 2. Are we okay with that?
Wait, how'd you get the center again?
I just found midpoint. Do you agree that it's going to have the same x coordinate? Because they're vertical? They're all going to have the same x coordinate. So all I had to do here was, what is the, I had 5 and, or excuse me, negative 4 and 0. Just add them together and take half of it. Okay. So now I'm going to start walking through to figure out my a's. And in this case, I'm going to find my a and my c. A is my distance from the center to the vertex. How far is this? 2. So A is 2. C is my center to focus. How far was that? For what? No, I'm just counting distance. Yeah, because remember you're going to square it later on anyway, so it doesn't matter. Yeah, the C value here is going to be 4. Everybody okay with that? So if A is 2, what's A squared going to equal? Good. C squared is 16. So what's B squared here?
20.
12.
In this case, for the finding centers,
Oh,
it was the
I'm
finding
looking at
the
the wrong
y
variables.
chord, right? It was
Sorry, folks.
Wait, can A ever be 0? Like, can the hyperbolas touch?
You won't have that then. You won't have
Minus? I thought it was.
it won't work
It's
that.
plus.
Because you can't divide that.
Oh, this is right.
The reason that it's 12 is because remember it's A squared plus B squared to get C squared. Do I have enough information to fill in the blanks now?
Yes.
Yeah, really straightforward here. So you get y plus 2 quantity squared. Please don't pop your gum. Over 4 minus x minus 5 quantity squared over 12 equals 1. And that's it.
Already.
Yay!
So, say A can A be negative? The intersects?
No, you're never going to have a negative because your a squared is always going to be positive because you're always going to be divided by a squared. Like I said, hopefully not very scary. It mirrors everything else you guys have been working on. Just a matter of counting some spots on your graph. Okay? Speaking of graphs, let's do one. Yay!
Let's know we put on for them.
You just smacked it.
I love
Wait, are exams like
gravity.
tests?
Best.
Are the exams like tests with?
Since you guys seem
Are we
coordinated.
gonna,
No, exams.
but are we gonna have like a test like all of it?
No, we already know.
I was actually at the start.
It's just over the last chunk. Now, that's why, remember I told you guys in part 1, part 2 on this? So you can have time to get high
No, but like, you know how like we're having 2 exams, are we gonna have like a test?
No, I'm just gonna, I don't know if you heard me, I think Clay asked me about that. It's just everything makes sense. It's just gonna be hyperbolas and systems, that's it.
Alright, so we're graphing.
No, I was gonna suggest that. Okay. First thing I would suggest as I'm writing this problem down, ladies and gentlemen, is I'm gonna put the first term over 1.
Yeah.
So I don't screw anything up later. Okay? Why is it up and down?
Why is
Y's first. Okay. Everybody agree this is gonna be up and down?
Yes.
Y's first. All right. Now, what's your H and K?
Or center?
All right. This is kind of a gimme. What if I do this? Let's make this Y plus 4.
Alright.
It's not difficult for you guys to do anything different in your work right now. What's my H and K?
Negative 1 over.
No, -1, -4.
Oh, H, you gotta do the H first.
Do X.
Because.
Hey guys,
Oh.
the only I'm gonna go back to why I did that. It goes HK. H coincides with the X values, K coincides with the Y values. In this case, your H and K is -1 and -1. You could get it wrong and still get it right. If this was a 4, if that happened to be a 4, the K value would be -4. Most people will tend to go -4 and 1 because that came first. Slow yourselves down and remember, you're already
Contact.
if you need to run in, that's fine, no big deal. A lot of, the only reason why I'm saying this is because a lot of people screw that up when they see it because they're accustomed to whatever comes first is the H. Remember, Y term came first, so that's a K value. H, then K. All right, just kind of remind you of that.
So we're doing 1 or 4?
We'll just go back with 1 because you guys already have that. Yes, sir. So now I'm just going to go ahead and continue from that. My A squared term is what? B squared.
1.
What's C squared going to be then?
5.
A is plus or minus 1, plus or minus 2.
Oh, wait. B squared is 4.
What?
Oh, what? I was looking
All right, so you get root 5.
at 1.
When we go to write this stuff out, once again, we're going to draw out our rectangular boxes. We're at -1 and -1. This is an up and down. So my vertex will be up and down. So all I have to do is just go up 1, down 1. The co-vertex is to the left and right 2. 1, 2. 1, 2. And now I just have to make my rectangular box. Draw in the asymptotes. And last week we had talked about there was that formula for finding the slope of the asymptotes, whether it was A over B or B over A. But like Clay was saying earlier, just do rise over run, guys. You drew this rectangular box right here. So just walk your slope. You went up 1, right 2. What's your slope? 1 over 2. So your slope of your asymptotes will be plus or minus 1/2. Okay?
So wait, A went up.
All I'm doing right now is write down the slope. If you wanted to do mx plus b, don't you have a point and a slope so you can go that way if you wanted to?
We only have to have the slope of it?
Right now I'm just asking you for slope. Yeah, I'm just asking you for slope.
Okay.
All right? Plotting your focus now. Your focus would be at, I have to add root 5 to, was it the x coordinate or the y coordinate? The y coordinate. So here's 1, 2-ish. And now it's just a matter of labeling out in order of comparison. And last time when I was looking at some of the stuff, you guys are doing this really well. So your vertices were at -1, 0, -1, -2. Co-vertices were at 1, -1.
-3, -1. How did you find, or what was the slope again?
When I did the slope here, I'm just doing rise over run. I go up 1 and I went over 2, just to get to the corner of the box there. It's much easier to do that than try to use some sort of formality or format or formula. One of those things. Some F word I don't want to say. That was weird.
I love the clown. I cried. The clown. I'm not
What
gonna
is,
deny it. I
wait,
cried.
what is it?
Anyway, the focus then is going to be at -1, and then I'm adding to my y value. So it's -1 plus the root 5. Okay. And that's how we set these things up. It's nothing scary, nothing, yeah, not like that clown.
His name is Twisty.
All I know is that I had heard that that show was going to be pretty good, and I was a big fan of True Detective and Fargo. Those were some of the greatest shows I've seen in a long time. The miniseries one, that was awesome. I absolutely loved it. And when people were like, hey, you should try this, like, so my wife and I started watching that last night. If you weren't afraid of clowns, you were by the time you got halfway into that.
His name is Twisty.
Twisty, sorry.
AMC makes great television.
He's not just a clown. His name is Twisty and he has feelings.
Okay, because that clown was freaky.
It's
And I will say, the focus, what I'm doing here is we added the root 5 and added the root 5, subtracting the root 5 from the center and added the root 5.
The estimated time.
Yeah, we went up 2-ish, because root 5 is a little bit more than root 4.
Because of his name.
So,
We didn't put our
do this one then.
things on.
Another graph, you guys do this one. I'm guessing that this probably wasn't as bad. Our center at 3, 2. Yeah. Can I simplify the square root of 34? Do you remember the easiest way to check? Better yet, what's half of 34? Can you do that again? No. Okay, so 25 is one of the oddballs. Okay, so that's an oddball too.
Well, those are obvious numbers.
What about 81?
Let me let you. All right, what's half of 144?
72.
Can you take half of that again? So it means you divide by 4 and go on. So anyway.
36.
All right.
42.
196.
Hey, 120.
Hey, all right, fine, I get it. Sometimes my trick doesn't work.
Yeah, you got that right.
Jeez.
Wait, no, it's like sometimes it works.
X squared came first. What direction is this going?
Sideways.
Sideways. Left and right.
Good job, Lincoln.
I did it wrong over.
A value is the distance from center to vertex, so I walk off 5 more. There's 8. 1, 2, 3, 4, 5. There's -2. Up and down 3, so here's 1, 2, 3. 1, 2, 3. Rectangular box, blah, blah, blah. Diagonals. Diagonals.
Wow.
Slope was up 3 over 5, so it's plus or minus 3/5. Okay? My focus. Remember, your focus is going to be further away because your vertex is always looking at it. So I'm going to take 3 and add root 34, which means it's a little bit less than 6. Out there. Subtract it. When you graph these, remember, hug your asymptote, go through the vertex, hug the asymptote. Hug the asymptote, vertex, hug the asymptote. Do you need me to list out your ordered pairs, or do we know that?
We know
No,
that.
can you, I messed up.
All right, ordered pairs. I know that I'm at, what's that? I went up 5 over, or went up 3 and then went over 5. Okay. Ordered pairs, my vertices. My vertices are at 8 and 2, negative 2 and 2. Co-vertices are at 3, 5, 3, negative 1. Foci are at 3 plus root 34, negative, or excuse me, positive 2, and then 3 minus root 34, 2.
Thank you.
You're welcome.
I messed up on the phone. I added 34 rounds.
Yeah, it's very common to screw that up, okay? So we've written equations, we've graphed, what's left?
When it's all like AX squared.
When it's all that weird stuff.
Quadratic 4.
Whoa.
So
And I'm not, yes ma'am?
I had a question on that last.
Yes, what do you got? Hold on, one second, guys.
With why was that 3 plus?
We're going horizontal here, so we're adding and subtracting to the x coordinate. So it's 3 plus the root 34 and 3 minus the root 34. So that's how we get this equation.
Oh, okay.
Because I can't say, it doesn't work as clean. Okay. Now, I'm not going to lie. When we get into working with completing the square style with the hyperbola, there will be a couple of things that I know right now you're going to do wrong. Okay? I'm going to do my best to point out little tricks and tips of how not to do them wrong. Okay? So we have negative 9x squared plus 16y squared plus 54x plus 64y minus 161 is 0. So when we did this stuff before, the first thing we always did was group them together. Do you guys agree? Yes. Now, here's what I want to do. When I group these things together, in order to make sure I don't screw something up, I'm going to put the positive square term first. So I'm going to put the 16y squared first. Here's the reason I'm doing that. By putting the 16y squared with the 64y, I'm going to have eventually a y minus something squared here. Subtracting out the negative 9x squared plus 54x equals 161. By doing that, I'm going to be able to factor out this negative 9 plus here to get my minus sign. Yes. Okay. One of the tricks here is if I'm going to have, once I notice I'm going to have a hyperbola, because there's one positive square term and one negative square term, I'm always going to put that positive squared grouping stuff first. Question? Yes, ma'am.
So that only for hyperbolas or
Yeah.
will be negative?
Yeah, because the other ones will be positive. Okay? So I want to put that negative 1 second. It just makes it easier. Okay? Yeah.
On the test, are we going to have to distinguish like which equation is for hyperbolas and so forth and stuff like that every week?
Well, I told you that it's only over hyperbolas and systems, so what do you think it's going to be?
Oh, never mind. When you say systems, yeah, that was. Oh, just like a bit.
So now when we get into this, the first step of doing these things was to get rid of whatever your coefficient was for the square term. So I'm going to factor out the 16. I get y squared plus 4y blank. And now I'm going to factor out negative 9. And here's another spot where you guys are going to screw up. If I factor out the negative 9, what's my next term? Minus 6. Good. All right. Now, on the other side of the equation, keep things balanced. We have our 161 plus 16 times something minus 9 times something. Before we would add in 16 and 9, now we're adding 16 and subtracting 9 because it's minus 9. Okay? That's usually the spots where you guys are going to mess up, is right here and right here. You tend to forget those negatives. Please be very careful. Okay? It's a very simple thing that you guys tend to do, all right? Now it's just a matter of completing the square. What's half of 4?
2.
Square it.
4.
So I'm going to add 4 to both sides. What's half of -6? Square it. I'm going to add 9 to both sides. So now my terms wind up being 16 times the quantity y plus 2 squared minus 9 times the quantity x minus 3 y squared equals 144. 144. I don't know if you guys have noticed, but more often than not, you get clean numbers. So if you're not getting clean numbers, what happened? You did something wrong. You done goofed. All right. Now what do I do?
You divide by 1.
Divide everything by 144.
You get
You get y plus 2 squared.
minus x minus 3 squared. 16. Look at that. Works out so nice.
They just switch
You
places.
could say, we're going like that.
Look, it does that every time.
I did it.
What direction does this go?
Up and
Up
down.
and down.
Up and down.
Up
This
and
one
down.
goes up and down. What's my h and k?
No. 3 negative 2.
3 negative 2.
Yes.
I caught it. I caught it. You didn't need to yell at me.
Okay. Everybody see it's 3 negative 2?
Yeah. 3 negative 2.
I gotcha.
Thank you.
Boom.
Yeah, we've done this one before. We would graph and list out all of our stuff. We always start with that and work our way down. What's my h squared term?
9.
9. So A equals plus or minus
What's b squared?
16.
What's c squared?
25.
So a is,
Plus or minus 3.
b is,
Plus or minus 4.
c is.
Plus or minus 5.
Yeah, this stuff never happens like this, does it? Okay.
Why does it only have just
Yes.
One problem.
3, 4, 5.
Well, yeah, when you get to this point here, if you know you can add 5 to 3, please do that.
What's 4 to 7?
Just put them in, you only worry about that if it's those roots you just can't. All right. Rootsy. Anything scary?
No. Homework, that's scary. Let's not do it. Oh no. I knew it. I knew it was too good to be true.
This is still 10.6 in the book, okay? So this is section 10.6. I know we've been bouncing back and forth on a 10.6. I promise you this is the last day you will be with 10.6. I think we've done 10.6 4 times now.
Yay.
Okay? Give me a second to load this up and I'll pull up a couple of problems for you so you don't have your book, you can start working on them.
No, dude, actually, I'm really bad. This class.